We're going to continue learning about complex numbers, and hopefully we remember how to add and subtract. I want to review the multiplication we did yesterday. If I had 4i times 2 minus 6i, I multiply this in and I get 8i, and I multiply that in and I get negative 24i to the second. But we learned that I to the second is just negative 1. So this is really negative 24 times negative 1, which is plus 24. So I have 8i plus 24, but this needs to go in front. So it would be 24 plus 8i. Everybody remember that? Okay, what if I had 3 minus 2i and negative 4 plus I? How do I multiply those? We would use the box. So 3 minus 2i on one side and negative 4 plus I on the other. And I would get negative 12 plus 8i plus 3i, and then minus 2i squared. But I squared is just negative 1, so I get rid of this, and I do negative 2 times negative 1 is positive 2. And now the negative 12 and the 2 add together to be negative 10, and the 3i and the 8i add together to be 11i. Everybody understand that? Okay. One of the things we're going to do when we deal with imaginary numbers, especially dealing with imaginary roots, is multiplying by conjugates. And we know what conjugates are. If I had x minus 4, what is its conjugate? It would be x plus 4. And when I multiply those together, I get x squared plus 4x minus 4x minus 16. And what do you notice? The 4x's cancel. And I'm left with x squared minus 16. And that will happen every single time you have conjugates. That's one of the nice things about conjugates is the middle term cancels. So if I had x minus 3, the conjugate for that would be x plus 3. And when I multiply them together, what am I going to get without actually doing it? I'm going to get x squared minus 9. Has to be a subtraction, right? If it's a plus, it's not going to work. Okay. If I had x squared minus 25, how does that factor? X minus 5 and x plus 5. We call this a DOPS, difference of perfect squares, and we call these conjugates. Okay. What about x squared plus 1? How would that factor? It doesn't. Why not? It's a plus. Right? It has to be a subtraction. We cannot say x minus 1 and x plus 1 because negative 1 times positive 1 is not positive 1, so that doesn't work. All right, what about 4x squared minus 49? Does that factor? Yes, it is a difference of perfect squares. What would the conjugates be? 2x minus 7 and 2x plus 7. Does that make sense? Okay. In the book, it's going to ask you to multiply some complex numbers by their conjugates. So if I had 5 minus 2i, and I multiply it by its conjugate, what would the conjugate be? 5 plus 2i. Okay. Now I'm going to use the box once to show you what happens. 5, oh, let me put it out. 5 minus 2i and 5 plus 2i. 5 times 5 is 25. 5 times negative 2 is negative 10i. 5 times 2i is 10i. And then 2i times negative 2i is negative 4i to the second. What do you notice? The 10i and the negative 10i cancel. What else? I squared is really just negative 1. So negative 4 times I squared is actually just plus 4. Does everybody understand that? Okay. And then I'm left with 25 plus 4 is 29. So that's sort of weird. I took two complex numbers and multiplied them together, and all of the i's canceled. And I got a real number, 29. Okay, that's going to happen every single time you do this. So if I had 3 plus I, what is the conjugate? 3 minus I. And the multiplication is pretty simple. Do I need to multiply those together? Yes, I would get 9. Do I need to multiply those together? No, because they're going to be the opposite of that. 3 times negative I is the opposite of I times 3. So I can skip those. Do I need this one? Yes. And what is I times negative I? Negative I to the second. But I to the second is really just negative 1. So what is negative negative 1? Plus 1. So this turns into plus 1, and I get 10. Okay? All right. 4 minus 6i and 4 plus 6i. I multiply those together, and I get 16. And I multiply these together, and I get negative 24i to the second. But I to the second is really just negative 1, so that turns this into a plus 24, which would be 40. Does everybody understand that? Okay. What if I had 5i? What is the conjugate? Well, it's kind of like saying 0 plus 5i. So the conjugate would be 0 minus 5i. Do I need those zeros? No. So it's just 5i times negative 5i, which is negative 25i squared, which turns into positive 25. Does everybody understand that? Do you need to see another one, or can I go on? Corby, you good? Okay. All right. The last one is we need to simplify some longer expressions. We need to bring all of these together. What would you do first? Distribute the negative 3 and the 2i. So I'm going to put this in there, and I'm going to put this in there, and that in there. 2 minus 6i plus negative 3 times 1 is negative 3. Negative 3 times 2i is negative 6i. And then 2i times 3 is 6i. And then 2i times negative 4i is negative 8i squared. But I squared is just negative 1, so that turns into plus 8. Now what do I do? Put all the like terms together. 2 minus 3 would be negative 1, plus 8 would be 7. And then negative 6i minus 6i would be negative 12i, plus 6i would be negative 6i. And we'd be done. Everybody understand that? Okay. And then they're going to throw you some weird things like this. When you run into something where I is bigger than 1, I recommend you simplify the i's before you do anything else. Okay? And I'm going to give you a little chart to remember. I is equal to I. I squared is equal to negative 1. I to the third is equal to negative I, and I to the fourth is equal to 1. And that's something we showed yesterday. If you just keep multiplying it together, you get those patterns. So before we start this problem, we need to fix the I to the third. What is 2i to the third? Well, I to the third is equal to negative 1. Let's lock this. So I to the third is negative 1. So 2i to the third is really just negative 2i. So I'm going to get rid of this, and I'm going to replace it with negative 2i. Okay? Well, what about I to the 7th? I don't have I to the 7th in here. But the pattern continues. So I to the 5th is going to be I, and I to the 6th is going to be negative 1, and I to the 7th is going to be negative I. So this negative 6i to the 7th is going to turn into negative 6 times negative I, which is really just plus 6i. And then you can use the box and multiply those together. Okay? Is that a little bit confusing? So let's say I had 4 minus 6i to the third plus 2 plus 8i to the fourth. What do we do there? Well, I to the third is negative 1, so it would be 4 plus 6, and, negative 1i, okay, plus 2, and I to the fourth is just 1, so that becomes plus 8. And then we would just simplify. 4 plus 6 is 2, plus 8 is 14, plus 6i. Does that make sense? Okay. What about 3i to the 8th minus 2i to the 7th plus 4i to the 11th minus 6i to the 9th? Well, I don't want to write a chart that goes all the way up to 11. So there's a trick we can do. This pattern repeats every fourth letter, right? I is going to be the same as I to the fifth, right? If I did another chart and I had I to the fifth, I to the sixth, I to the seventh, and I to the eighth, these are going to match. Everybody see that? And if I had another chart where I had I to the ninth, I to the 10th, I to the 11th, and I to the 12th, those are going to match. So all we really need to know is 1 through 4. And then we can change the numbers we're looking at into that first chart. Does everybody see the pattern? It repeats every fourth one. It's going to be I, negative 1, negative I, 1. And then the next chart will be I, negative 1, negative I, whatever. It's too early to say that. So what we do, instead of memorizing a whole bunch of items, we just use this chart and we just adapt the numbers we have into something smaller. So the first one is I to the 8th. I do 8 minus 4, and I get 4. So I to the 8th is exactly the same as I to the 4th. So that would be 3 times 1. Okay? And then I to the 7th, 7 minus 4 is just 3. So I to the 7th is exactly the same as I to the 3rd. And I get negative 2 times negative I, because I to the 3rd is negative I. Okay? And then 11 minus 4 is 7. What do I do now? Subtract it again. Subtract 4, and I get 3. So I to the 11th is the same as I to the 3rd, plus 4 times negative I. And then for the 9 minus 4 is 5. 5's not on my chart, so I subtract again. And I get I to the 1st. So negative 6 times I. Does that kind of help? So 3 times 1 is 3. Negative 2 times negative I is plus 2I. 4 times negative I is negative 4I. And negative 6 times I is negative 6I. And now I just combine like terms. 3. And then 2 minus 4 is negative 2. Minus 6 is negative 8I. Does that make sense? Okay. Say I had 4I to the 5th minus 8I to the 13th. And let's times that by 2I to the 9th plus I to the 17th. My recommendation is you make all of the changes before you multiply. That will make things much, much easier. Okay? So make all of the I changes first. I to the 5th, we take 5 and we subtract 4 from it, and I get 1. So I to the 5th is the same as that. So I get 4I. And then 13 minus 4 gives me a 9. So I need to subtract again. Minus 4 is 5. What do I do with the 5? Subtract again. And I keep subtracting until I get a number that's on this chart. I to the 1st. So minus 8 times I. Okay. And then I to the 9th. 9 minus 4 is 5. Minus 4 is 1. So this would be 2I plus 17 minus 4. That's still too big. Minus 4. Still too big. And I get all the way down to I to the 1st. So plus I. Now what should I do? I could use the box, but in this case, I can actually do something that's easier. Don't I have like terms inside the parentheses? I can put these together. Now the box will work and you'll get the right answer. But that is just negative 4i. And this one is just 3i. So I end up with negative 12i squared, but I know that I squared is negative 1. So it's just negative 12 times negative 1, which is positive 12. That makes sense, Ollie? Kind of. Do you need to see another one? Do you guys want to see another one? Okay. So okay. So all of my i's are too large. I need to adapt them. I just subtract 4 until I get a number between 1 and 4. So 6 minus 4 would be 2. So this 6 is the same as I squared. And I know that I squared is negative 1. So I can change this to 4 minus 3 times negative 1. Because I to the 6th is the same as I squared, and I squared is just negative 1. For the next one, the 10, 10 minus 4 is 6. That's too big. Minus 4, and I get 2. And I to the 2nd is just negative 1. So negative 12 times negative 1. Okay. The next one is I to the 15th. 15 minus 4 is 11. Minus 4 is 7. Minus 4 is I to the 3rd, which is this row. So I to the 3rd is the same as negative I. I just replace the I to the 15th with negative I. And then I simplify. 4 plus 3 plus 12 minus 3i. And then 4 plus 3 is 7, plus 12 is 19, minus 3i. That is the simplified version. So if you have i's with exponents larger than 1, you want to do those first. Figure out the i's and then simplify and combine like terms. All right? So I think last time we ended at 48. So you need to start at 49 and finish the rest of that. Okay? All right. Good luck.